So today we're going to a system design interview. We are going to build a Instagram feed feature with a focus on the front end. This is one of the most common system design interviews that you will encounter as a front-end or a full-stack developer. We will also share with you the 5 most common mistakes developers make in system design interviews and a 4 steps framework that you can use to solve any system design interview problem, front-end or back-end. Bogdan, are you ready?
Yes, let's go.
Okay, well, I sent you a link with the instructions. Can you pull that up? Yeah, okay, so that's our task. We are going to design, to go to the system design of this social media feed. Now, I do want you to focus exclusively on the feed, okay? So forget about comments and likes. Do you have any questions?
My first question would be, are we focusing on the mobile app or the web app use case?
So for this time, we are focusing on the web side of the app.
Then let's get started. I guess the first thing would be to actually understand who's going to use this and what are the features we need. So from what I see, we're going to see different posts. I see there are images. Do we also have video included in this feature?
We might have video, but for now, let's leave it out. Just assume images, image post with a bit of description, some descriptions, just like you see it in the image.
Okay, perfect. So we have some image posts. There might be some text component. Perfect. And about the likes and the comments and all these share buttons, do I need to care about all these too? Okay, so the buttons /likes /comments out of scope. That simplifies things a lot. Perfect. Okay, let me think. So I'm assuming the users will be scrolling a lot. They can also create posts. How many users do we think we will have on this application?
I mean, you could assume 1 million daily active users, 1 million. And just for the sake of the use case, let's suppose each user will create around 1 daily post.
Okay, 1 daily post per user. That's what they create, but I guess they also scroll. So how much time they spend usually, how many posts they consume?
Yeah, I assume they will consume around 100 posts.
Okay, is there any pattern to when they log in? Is there any seasonality, like are they more active in the evenings? Is there any peak traffic?
Yes, so you have 2 peak traffic moments. Peak time around 1 p.m. at the lunchtime, and let's say 9 p.m. in the evening when people actually scroll. And what's a peak time? For us, it will be around 70% of the users are active at the same time.
Okay, we're gonna have to take that into account when we talk about scalability. Okay, so we focus on the functionality of the scrolling part, not necessarily the taking a picture, creating it, creating the thumbnails and different versions of this picture. I'll focus a lot on the scroll part. Is that right?
As you can see, Bogdan is now in the middle of the first step of this system design interview framework. Quick note, as you can see, Bogdan already started with the first step of this system design interview framework, which is requirements analysis, right? Going from ambiguous requirements like he's presented with an interface to concrete system specifications. Now, before he dives further into that, let's talk about the number 1 mistake developers make in system design interviews, which is to assume too much and don't spend enough time clarifying requirements. Remember, you are being judged not by the answers you give, but on the questions you ask, especially in the beginning of the interview.
Okay, so we have our social media feed. We're going to have image post. Do we have any information about the size of the image?
Yeah, let's suppose on average 1 megabyte.
Okay, so that's a 1 megabyte image. We're not going to talk about the buttons and the likes and comments. We have 1 million daily active users, but there's an asymmetry on consuming versus creating posts. I would just call this the read to write ratio, read/write, and we will use this later on in the design. We'll have a lot more reads from our post service or whatever will deliver this post than actually writing. And most users are online 9 p.m. in the evening, so 70% active of the 1 million daily active users. That's around 700,000. I'm gonna add it here, 700,000 peak time. Okay, now if they are active at 9 p.m. in the evening, 700,000 of them, and they consume around 100 posts, that means we will read the posts 100 times 700,000. Well, those are big numbers over the span of what? When you say 9 p.m., I'm assuming maybe a 2-hour window around 9 p.m. So 8 to 10. So this is basically roughly, and these are very rough numbers, but it would be this divided by how many seconds we have in 2 hours. So basically we have 2 hours by 60 minutes multiplied by 60 seconds. So whatever the result of this is would be the kind of request per second. Let's call it APS, which is request per second. What I'm trying to get here is how much load we will have on our service. So I would say this maximum load, given our usage, this is what we can expect in terms of system specifications. The other thing is the data throughput. So we have a 1 megabytes image. They are downloading 100 of those over 2 hours or however they spend scrolling. So we'll also have a throughput capability or capacity problem. We can maybe talk about that later again, but I'm going to add here like we have a throughput issue. Most of those we can solve with cloud services. I will try and sketch a first version of the system that we need to satisfy this kind of functional requirements. Sounds good?
So as Bogdan mentioned, now that the requirements are clear, he's going to move on to the second step of the system design framework, which is building what we call the minimum viable system. Basically putting together the minimum number of parts to satisfy those requirements. Which brings me to another mistake developers make in system design interviews. That is not getting enough buy-in from the interviewer. They forget that the main goal of the system design interview, it's not solving the problem, but showing the interview how you think about the problem and making them part of the process. How can you do that? Ask questions, which is what Bogdan will be doing constantly during the next section.
Okay, so I'm going to go ahead and just draft the first version of what we would need here. And for the sake of this first iteration, let's say I will not care too much about those numbers and the scalability part. Let's just get it off the ground. So the first thing we need would probably be a web app, because our users will need to find us. So we'll have some sort of a web app that has the whole scrolling component. So we definitely need some sort of a backend that contains, I'm going to call this the feed service, that contains our data about the feed, basically the image, the title, and the description. But of course, we might not want to store the image directly here. It's just a lot easier to maybe have it somewhere here. I'm going to call this like an image blob storage, which is one of those very simple cloud services to store images. As we see, there's so many of those that we need something very scalable. Even for a first version, we need a huge place to store all these thousands of images, terabytes and terabytes of image data. And what will happen is that the feed service will persist images over there, and then the web app will consume, because the feed service will send back like the URL of that image. We need the database too. So I'm just going to add another square for a database to store kind of the post metadata when it was created and the description and all those kind of things. I feel like a non-SQL database should do. Much more scalable for the future use cases, and we don't need so many relationships for now. Is there anything else that we need? Let me double check our requirements. Yes, probably this would be it for the minimum, kind of the minimum architecture.
Okay, before we proceed, one key mistake that you want to avoid at this stage, it's running out of things to say. Just like Bogdan did, you need to be proactive. And this is not easy because at the same time, you don't want to become controlling. How do you do that? Well, you drive the conversation forward without forcing it. You can do this by using open-ended questions. Like, for example, hey, is there any specific part of the system you want me to focus on? Okay, now back to Bogdan.
Perfect. So now that we have our minimal architecture, I'm just going to go ahead and try to see how would we scale this. And for that, let me just bring this number up. Let me run this through my calculator. I can use a calculator, right?
Yes, you can.
Okay, so my calculator tells me this is around 10K requests per second. So I'm going to add that number here. So we have 10K RPS over here. Do we have any data on geography? Not yet. So this data, would it be Europe, the US?
Let's assume the US, and let's assume most of our users are based around in cities where there's more population density.
Okay. Because of course 9 p.m. would be different from the East Coast to the West Coast, but I would assume, let's assume this is the East Coast. We have this kind of 10,000 requests per second. I'm going to start scaling from the client towards the backend. So on the client side, probably the best thing would be to add a CDN for the application itself. So I'm going to put it here. A CDN, it's a content delivery network that will basically distribute our static assets close to the users. So all our JavaScript and CSS, which will make it a lot more scalable. It also there's no unique point of failure because the application is distributed. So it also helps us with not only scalability, but availability too.
So as you can see, now that the minimum viable system is done, we will move on to step number 3, which is what Bogdan was getting into. That is scaling the system that he just outlined. So Bogdan, back to you. How can we go about scaling this application? You already mentioned the CDN.
Yes, so I'll probably add the CDN for CDN, Content Delivery Network, CDN, for our web app, and then probably another one for the image storage. So this will go like this, right? That would be our first change. And so that would mean that at least the image, the static part, okay, I'm playing around with these arrows. Let me finish this. Perfect. So we have now 2 content delivery networks. They manage our static assets. The read now is super scalable, but what would happen is there's a lot of pressure on our feed service and the database. The web app, we don't have a scalability problem because it runs in the browser of each user. So as long as it's performant and well optimized, maybe we can talk about that at the end, we should be fine. Now, I would expect a lot of pressure on the feed service, and this is when things get interesting. I think I mentioned before this read to write ratio. I will just put it here. We have a 1 to 100 read to write. And we can use this to simplify a bit the way we scale it. One of the easiest things to do would be to separate this feed service. So we would have a read feed service and we would have a write feed service. And this would live independently. And what that will allow us to do is to scale very quickly. So what do I mean by that? We're going to have our write service, and then we're going to have our read feed service. This one will take a lot of load. And this is why we will probably end up having sort of a load balancer, which is a component that will distribute the traffic to a fleet of instances, which will allow us to scale horizontally this read service, which again takes most of the pressure. So let me just draw a couple of instances here. And this is how our final architecture for this part will look like. We'll talk about the database in a sec. But is it clear so far?
Yes, it's clear. So you separated the read from write functionality, so you're able to scale them independently. Another mistake that developers make at this point of the interview, it's talking about things they don't know. They try to be proactive and to move the conversation forward, but they risk moving into things they don't know about. Like if you're a front-end developer, database scalability, it's something you're not probably proficient at. If you want to talk about the scalability of the system as a whole, you want to keep the conversation focused on the parts that you know best. And if you're a front-end developer, everything that happens in the client, everything that happens between the server and the client, and maybe a bit of server side. And this is exactly what Bogdan has been doing. He started talking about scalability in the web app first. Now back to Bogdan and back to the read and write service.
Perfect. So the last bottleneck here would be our database, which still receives a lot of pressure. With the requirements we have so far, we could probably go for a NoSQL database here.
Can you tell me a bit more about this choice? Why NoSQL?
So the reason behind this is because NoSQL gives us the scalability out of the box kind of advantage. It's a lot more scalable than the SQL kind of structured databases, especially if we go for a document database, for example, like Mongo. But at the same time, we do not really have a lot of relational data here. These posts are pretty much related to the user, and that's pretty much it. So if we had a more complex data structure, if we had complex relationships, we would probably go for a SQL database like MySQL or Postgres. But I think given the use case, we can get away with a NoSQL document database.
Yeah, so it's not only the scalability factor, but also the shape of the data that you are handling that you need to consider in this decision. That's what I wanted to see. Cool.
Perfect. And this would be pretty much it, because NoSQL with Mongo, it can scale pretty well. Like we shouldn't have too many issues here. Now let me take a second look at the system and see if there's anything else we can do to make sure this will scale pretty well. So we have our CDN. And we have our write service that will create the images. There might be some asynchronous work here. I didn't ask about creating thumbnails, optimizing the images before we persist them. Maybe we can do that asynchronously with something like a serverless Lambda. The cool thing about that kind of jobs is that they can be asynchronous, so they scale pretty well. And probably the one thing missing would be we could also leverage caching for the read service. So I would assume we could probably place a cache or a Redis base cached here over. Let me just paint it in. And so because I imagine posts do not change that often, I didn't ask that in the requirements, but I would assume people don't change their post, or we don't give, Instagram doesn't really give the ability to change too much. And we can leverage that to really cache this. For example, you could cache the viral posts because we know that everybody will request those ones, and we can have them. We can have the metadata about them, like the post description and so on, in a Redis cache or sort of a very high performant cache memory, and that will make things even faster when we read posts.
Okay, now really quick, another mistake that we see developers making here, it's being too implementation focused. As you see, Bogdan was able to keep the conversation high level, but at the same time zoom in and zoom out and not get too bogged down by the implementation details. And this is what developers do. They miss the big picture. Like they start focusing way too much into a single component that they know, and they get lost in the implementation details and give the impression of a junior dev. Split your focus between all components of the system as much as you can, and you will do much better than getting bogged by implementation detail and coming across, again, as a not experienced developer. Now that we are almost over with the scalability of the system, Bogdan is going to move on to the last piece of the puzzle, which is scaling individual components. Okay, Bogdan, so great job. We have kind of the full picture. We have the full system. Now let's focus a bit on the web app. And when we are looking at the web app, right, we will have a few hundred posts being rendered at the same time in this web app. Do you see any performance issues that might arise in that case?
So let's take a look at this one component. Are we using any component framework? Do I need to take that into account? Is it a free choice?
Yeah, so to keep it short, we will use React in this case. So don't spend too much time on why we use React. It's one of the most common used, and we can have that discussion either way. But for now, just assume we are using React.
Okay, so I would assume that this is our viewport in a mobile device, and we start scrolling. So we'll end up having all those elements mounted, which are our posts. Let me see if I can visualize this somehow. Okay, so we have one of them, and I'm scrolling down, and I see these ones at the moment, but then I'll keep scrolling and have all those elements here. I guess one of the big problems will come because we have a DOM and a virtual DOM that will be too big. And I think the browser even has a limit on how many elements you can add to the DOM. But it will become very heavy, especially if they are using a mobile browser. This will be very heavy. So I guess one of the things we could do is to unmount the posts that are not visible outside viewport. So these ones, for example, we would just unmount them. We keep the reference that they are not referenced anymore. And I think what some companies do, I think Facebook will render an empty div here with a hidden, sort of a hidden property. The repaint of the browser do not take those into account, but they still are calculated in the scroll. So it doesn't, the fact that we move something out doesn't affect the scroll lines. And if I recall well, there is a package they built for this, which is called virtualized lists. So we need something like this. We need a way to remove and add elements to sort of this sliding window. Like as the user scrolls, we just render the next ones they will see, either up or down.
Okay, Bogdan, so I understand that's how you would go about rendering this post, but what about fetching them?
Sure. So when it comes to fetching those, I guess the first idea that came to my mind was having some sort of a pagination. So basically we would have a page, let's say page equal to 5, and then whenever they scroll down, we show a loading indicator or we prefetch the next 5. I'm assuming if my friends, for example, publish new posts, then the content of page 5 might change all the time. So I might go, imagine I'm on page 5 and I go to page 6, but there were some posts published I would probably see some posts from page 5 in page 6 because they get pushed down to the next page. So I guess it's probably better to do a cursor-based pagination. I'm gonna add here cursor-based pagination here, linked with something like intersection observer. I used this API before, but we basically, the cursor would be the ID of one of those posts, and we just instruct to render, the next 5 after this one. And so when people scroll, we just change that one cursor. And the advantage there, if we get new posts added here, it doesn't really matter. We don't shake kind of the scroll. There's no complex logic that we need to implement here. So probably cursor-based pagination would be best, and use the intersection observer to virtualize this list and to basically unmount what is not in the viewport.
One final question about web performance. Do you think this would be a good use case for server-side rendering?
A good use case for server-side rendering? Out of the bat, my answer would be no, because there's so much state on the client and there's so much interactivity that we don't get so many advantages. There's not so much to pre-render on the server. We could probably be able to pre-render everything else around the feed, but the feed itself sounds like a very interactive, a very state-heavy component, and I don't see any benefit from trying to render this in the server, especially because people will immediately scroll, so you don't get a lot of advantages for just having something pre-rendered. But everything else around the feed feature, I think we can pre-render, yes. We can server render.
For the sake of this video, we will stop here. Make sure you also check our senior interview questions video. As for me and Bogdan, we will see you in the next one. Take care.